This is some information about the Java programming language. Of course, it's an object-oriented programming language. The official implementation is owned by Oracle Corporation. It's used for both front-end and back-end apps, and its use is widespread. All the way from Android apps are in Java, embedded systems such as in televisions, a lot of those are in Java. Some desktop apps such as Minecraft is in Java, web apps, and then you've got server-side apps and enterprise apps, scientific apps, and even financial apps. And so what really makes Java different is that it is both compiled and interpreted. Okay, so for example, a compiled language is you write the source code, such as C++ source code, and then before you can run it, you've got to compile it into machine code. Of course, that machine code, or the executable that you compiled, that is platform dependent. So if you compile your C++ program on a Windows computer, then that executable will only run on Windows, and if you compile it on a Mac computer, that executable will only run on Mac. Then you distribute your app, and then the operating system runs the executable, or the machine code, for a compiled language. And compiled languages are known for speed. So compiled languages such as C++, that's used to write the operating system, or a lot of the operating systems, including Windows. Okay, so now, an interpreted language is you write the source code. Sometimes they'll call it the script, for smaller programs. You write the source code, and then you distribute the app, and then an interpreter runs the program line by line. So it's not compiled into an executable. Okay, so for example, with JavaScript, most web pages have JavaScript in them. You can actually see the code. If you look at the HTML code, you'll see the JavaScript in there. And then the interpreter that runs the code line by line is the web browser. So one of the big advantages of an interpreted language is platform independence. So if you create a web page that has some JavaScript code in it, then that JavaScript code will execute whether you're on Windows, on a Mac, on an iPhone, on any platform that has the web browser, that includes the interpreter to run it. Now, one disadvantage of this is that it's a lot slower to execute, being an interpreted language. But in the case of things like JavaScript, speed isn't everything. I mean, because the code is small, relatively small, so the speed really doesn't matter. Of course, another very popular interpreted language is Python, which is used for both little scripts and also some larger applications. Okay, so now Java. What you do in Java is you write your source code, and then you compile it into something called bytecode. And this bytecode is similar to machine code. I kind of call it like generic machine code. So it's not made for a specific CPU, because the machine code, the instruction set on each CPU is a little bit different. So it just compiles it in something that's similar to assembly or machine language. But then when you actually run it, you need the Java virtual machine installed on the platform to run it. And that does the interpretation, or, converts it into the actual machine code for the CPU that's on that platform. Okay, so the advantage is this bytecode is platform independent. So if your bytecode, so you can take that bytecode that you've compiled onto any computer that has the Java virtual machine, and then it will run. So, and since it's compiled into this bytecode, it makes it very fast. Almost as fast as a compiled language. Not quite, but almost as fast. And of course, now there's always exceptions to this. Someone has created an interpreter for most compiled languages, and someone has created a compiler for most interpreted language. So there's always exceptions. Okay, now let's see it in action. So here is here's a program right here, a program to recursively calculate a Fibonacci number. So here's a recursive Fibonacci method right here in Java. Okay, so now to run it using the Java tools on this computer, I'm going to run it from the command prompt. Now, most of the time, most programmers will probably use an IDE that does the compiling and running for you, but you can, if you install the Java development kit on your computer, you can certainly do this from the command line or on Mac from the terminal. And there are plenty of programmers that prefer to do it this way. So to compile, here is my source code right here that I just showed you, fib.java. To compile it using the JDK tool, the javac, Java compile command, and then type the name of the file, fib.java. And so now it compiled it. If there were any error messages, you would see them right here. And then, IDEs will capture the output of this compiler right here to display your error messages. And then now I'm going to do a directory so you can see what was created. So now what was created is this .class file. This is the bytecode that was created. Once I compiled the fib.java, it created this bytecode file right here, fib.class. And to run it, I just type java space fib, and that will run the class, the bytecode, the .class file. And so this is your Java virtual machine that is running it right here. So I run it, calculate a Fibonacci number. So what's the 40th Fibonacci number? It's this large number right here. Okay, so that is how we compile and run a Java program from the command prompt. And again, probably most people may use an IDE that does these Java compile and Java run commands for you. Okay, so now here are the different parts of the Oracle distribution of Java. So the heart is the Java virtual machine. So, and what that does is convert the bytecode to machine language. And we did that when I typed Java fib. So I invoked the Java virtual machine. Now that is contained within the JRE, the Java Runtime Environment. And that includes class libraries that you may use within your programs right there. So when you do an import java.util, that is part of the JRE. So if you install the Java Runtime Environment, it also installs the Java Virtual Machine. But then if you're a programmer, you may install the JDK, the Java Development Kit. And when you install that, it contains these elements here. And of course, this contains development tools such as your compiler, javac command that we just did. Okay, and now the last slide right here is just a few more little details about the Java language. So here are the file extensions, the most popular file extensions that you'll see. Of course, the .java file extension is your source code. And one of the first things you learn when you start programming it is that your file name must match your public class name inside the source code file. And so then once you compile that into bytecode, it creates the .class file. And this file can be executed by any platform that has a Java virtual machine. So again, I'm on Windows right here, but I could take this into my Mac, the .class file, and then run it the same way I just did here on Windows. Another extension that you might see is a .jar, a Java archive file, and it uses the zip format. So this is a way of packaging an application, a Java application that contains a lot of files. So for example, your application may contain your bytecode files, images, audio, etc. And so this allows you to package it into a single file for distribution so you can distribute it with just one file. And there'll be a command that you can run the jar file. Another thing that is good to know about Java is that there is such a thing called Java packages. So a Java package is used to group related classes. So you've got multiple files for your application, and and each file is a class. And so the package, you'll see a package header at the top of each file that groups them all together into an application. So this helps organize everything. And I'm not going to really demonstrate it here, but if you wanted to compile it, if you wanted to run a package, it's just a little bit different. You have to throw in a parameter right here. So anyway, that's all I wanted to cover with the introduction to Java.